Okay, so calculus. So what is a limit? Well, a limit is just something that approaches. If you've taken pre-calculus, you know that a limit can be used to represent any behavior as such. You would say like the limit as x approaches infinity of f of x, which is your function, is equal to infinity. So the limit, so this is saying that as x gets nearer and nearer to infinity, that our function f of x is also getting closer to infinity, okay? So that's all that is saying, is it's just a value that our function is getting closer to as x approaches, or x or some other variable approaches that value. Okay, so now that we know that, what we can do is we can actually apply this knowledge to finding the limit as x approaches 0 from the right. So this means from the right, right? You can either approach a function from the right or from the left or from both directions. Both directions if you leave this blank. From the left if you make this a minus sign, and from the right if you make it a plus sign. Okay, so we're approaching this from the right. We know that this looks like this, right? And so this is log of x. Well, we know when we plug in 0, right? We get log of 0, which is error. That, you can't find the log of 0. But we know when we graph it that it's negative infinity, but let's actually prove that, okay? So let's take an example, right? So in order to actually solve this, we need to know something called differentiation. Differentiation is finding the slope at a certain point on a graph. The function that models the slope of a function is known as a derivative. The derivative of that function models the slope for that function. And you model the derivative with the symbol f prime of x, or with something known as dy over dx, which is just a fancy way of saying the derivative of y in terms of x, okay? It's not actually a fraction, but you can use it as a fraction, and we talk about that. And you can see my website, and on my website we talk about slope, fields, differential equations, and you can actually use the dy over dx as a fraction in that case, but go check that out. All right, so now let's go back to this. So the definition, so as I've drawn here, we have the curve x cubed, right? Y equals f of x, which is equal to x cubed. So how do we model the slope at a point? Well, we use the tangent line. But how do we know what the tangent line is exactly? Well, we can actually use what we know with a linear line by finding 2 points and then connecting them. So this is known as a secant on a curve. But as you can see, the tangent actually looks like this, right? This secant right here is nowhere close to this tangent line, all right? So we just grab points that are closer and closer and closer to this point until we reach that point, and then we know what the tangent line is. So we're approaching that point. So say that the distance between these 2 points in terms of x is delta x, right? And so this point is at the point x f of x. So in this point is at x f of x, and then this point would be at x plus delta x f of x plus delta x, right? And so if we just want to find the slope, then we can model that here. So the slope is change in y over change in x. So our change in y is f of x plus delta x minus f of x, and that would be over delta x, which is our change in x, right? And so then we just plug this in. We just plug in our values to our x cubed, right? We get x plus delta x cubed minus x cubed over delta x. And then we do binomial expansion, x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus x cubed. We cancel out the x cubed. We see that delta x is in all these terms that are left over. We cancel it out. And we're left with the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared. Well, we know that delta x is approaching 0, so we know that this whole term is going to become 0, this whole term is going to become 0, and we're left with just 3x squared. There's no delta x here, so as delta x approaches 0, 3x squared is just approaching itself, 3x squared. Limit as x approaches negative 1, x squared minus 1 over x plus 1. All right. So how would we find this? Well, there are 2 ways we can do this. One, we can factor it out, cancel it out, and we end up with just x minus 1 times x plus 1 over x plus 1. Cancel out x plus 1, we get x minus 1. So negative 1 minus 1, we get negative 2. Or we can do something called L'Hopital's rule. L'Hopital's rule is where we take the derivative of the top and the bottom because the relationship stays the same even if you take the derivative of the fraction, right? So in that case, we take the derivative. So there's something called the power rule. Power rule just means that if you have the function x to the n, you take the derivative of that like this, then you end up with n times x to the n minus 1. All right, so that's what the power rule says. All right, you can check out more about power rules and all the rules of derivatives on my website, but this is just a brief review of limits, okay? So in this case, the limit is going to be x squared minus 1, well that's 2x, negative minus 1 goes to 0, so it's just 2x. X plus 1, 1. So we end up with 2x. As x approaches negative 1, we end up with 2 times negative 1, which is negative 2. All right, 2 ways to solve the same problem. And I hope that you gained something from this lesson and you will do well in calculus.